Hi, I'm Mr. Franklin, and welcome to this video where we're going to look at the soccer ball on the grass, which is part two. Yesterday we had looked at a ball floating in space. So now we've got our ball with the mass M sitting on the grass. It's the same soccer ball, so the mass is the same as it was before. Let's talk about the forces acting on the soccer ball. It's sitting on the ground on the earth, so the force of gravity, also known as weight, is pulling it down. By Newton's third law, there's a reaction force called the normal force, and it's pushing back up. That has to be equal and opposite. So when I add up all the forces, force normal plus the force of gravity, they're going to cancel each other out, and you're going to have a net force equal to zero. Okay, it's sitting on the ground. It's not moving anywhere. It's not changing its motion, so its acceleration is zero, which means its velocity is zero. It's at rest. It's amazing. And so my armless soccer player is going to come running along and kick the soccer ball. We're going to have the force, we're going to assume that it stays on the ground too. But we have the force of gravity pulling the soccer ball down. We have the normal force reacting straight up. Those are going to still cancel out. We're also going to pretend that the kick was directly in the center of the ball. And so there's no like lift or downplay on the ball, all that kind of stuff. It's right in the center. So the ball is going to go straight out that way, okay? When we kick it. So the force of the kick is positive. So we're going to get a positive acceleration. So the velocity is going to be positive. And as long as there's a net force, it's going to increase at an increasing rate. Once the force is gone, that velocity will actually be positive, okay? But as long as the force is applied, it's going to be increasing at an increasing rate in this case, okay? So velocity. Now it's rolling along the grass. There's nothing else kicking it. The only thing it's interacting with is the grass. So we have this thing called friction, which basically any two surfaces that interact, friction pushes in the opposite direction. Okay, so friction is pushing the opposite direction, slowing the soccer ball down. If I add up all these forces, normal force, gravity force, and friction force, the result is going to be a negative force of friction. So negative force means a negative change in motion, negative acceleration. So the ball is going to be positive, just going positive, but it's going to slow down. So what does that mean? It means the velocity is going to decrease. And depending on the size of friction, that could decrease at an increasing rate or decreasing rate, but the speed is going to decrease. Now, eventually, it will slow and stop. The force of friction will come to a point where everything balances out and the force is equal to zero, acceleration is zero, and the velocity is zero. So big thing I want to point out with this is we can have forces acting on an object and it's not be changing its motion. So even here, we have forces acting, so it's not going up and down, so the ball is just going left and right. So let's do a quick recap with some plain English. So first, the ball is at rest. We got gravity and we got the reaction force of the ground pushing up. Here, you're going to kick the ball. It's going to accelerate during the kick and have a positive velocity. When the kick is done, we have a positive velocity, but it's going to slow down. And then over here, it's going to come to a stop and be at rest. So that concludes this video on Newton's first law with the soccer ball on grass.